Hi class! The next topic is the Newton's second law for rotation. We are familiar with the Newton's second law for linear motion where the equation is the summation forces equals to mass times the linear acceleration. The same concept applies with the Newton's second law for rotational motion where torque is the force equivalent in rotational motion. I, or the moment of inertia, is the mass equivalent in rotational motion, and the angular acceleration is the equivalent for linear acceleration. Next, to derive the unit of torque with this equation I times alpha from the general equation of moment of inertia mr squared, where m is in kilogram, which is the mass of the element. R is the distance from the axis in meter. We get kilogram meter squared. Then, for the angular acceleration, this in the radian per second squared. This one is only a placeholder. So we will ignore this one. Then we get kilogram meter squared per second squared. Then, factoring this quantity, kilogram meter per second squared, this unit is also equivalent to Newton times meter. Therefore, the unit for torque is in Newton meter. Okay, let's solve a problem. Consider the father pushing a playground merry-go-round in the figure. He exerts a force of 250 Newton at the edge of 50 kilogram merry-go-round, which has a 1.5 meters radius. Calculate the angular acceleration produced for part A when no one is on the merry-go-round, and for part B when an 18 kilogram child sits 1.25 meter away from the center. Consider the merry-go-round itself to be a uniform disk with negligible friction. When we say uniform disk, it is also known as a solid object. So, ibig sabihin po, evenly distributed yung mass ng object. Then, so here is the illustration. Yung force applied is at the edge of the merry-go-round, and the distance or the lever arm from the axis of rotation is equal to the radius given 1.5 meters. So we know that the torque is also equal to force times D. So, ito po magagamit natin. Yung D dito is the distance from the axis of rotation to where the force applied. So, yung D is also equal to R. Then, yung force po is perpendicular with the radius. So, yung sine theta natin dun sa equation ng torque is equal to sine 90 degree or equals to 1. Okay. So, this is our solution. So, once you have listed all the known variable, we have the force equals to 250 Newton. The mass of the merry-go-round equals to 50 kilogram. The radius is 1.5, and the unknown angular acceleration for part A when no one is on the merry-go-round. We have to solve this one using the Newton's second law for rotation. Okay, so we can substitute T equals to F times D, where D is also equal to the radius. Kasi kung makita mo, yung force applied, ang location niya from the axis of rotation is equal to radius. So here is our new equation. Fr is equal to I times alpha. We have here the known variables F and R. The only unknown variables are the I and alpha, where yung I po masasolve natin using the formula for moment of inertia ng solid object, since ito is uniformly distributed yung mass sa solid po yung merry-go-round. So yung I natin is equal to 1/2 mr squared. So ito yung gagamitin class pag yung I natin or yung element dito is solid or uniform disk. Then substituting the given mass is 50, then the radius is 1.5, we get I equals to 56.25 kilogram meter squared. Then now we can substitute it back to our formula. So using the calculator, we can compute the alpha equals to 6.67 rad per second squared. Now let's move on to part B. So here we have another parameter where meron na pong mass yung child. So from 1.25 meters, meron daw nakaupo ng child dito. So kaya sali siya sa moment of inertia kasi magkakaroon siya ng mass dito. So may resistance siya sa angular acceleration. So sa moment of inertia po ng child, mako-compare natin siya sa moment of inertia ng hollow cylinder. Pag hollow yung cylinder natin, ibig sabihin, yung elements natin is nasa surface lang. So, kamukha siya nung point load dito ng mass. Point load ng child. Okay? Kaya yung I ng child is equal to mr squared. So, pakicheck na lang po ng formula ng hollow cylinder dun sa naunang video. Then, yung moment of inertia for part B, kukunin natin yung sum ng dalawa, yung moment of inertia ng merry-go-round and child. May nakuha na tayong I for the merry-go-round. Yung kailangan na lang i-add is the moment of inertia ng child. So 18 times 1.25 squared. So getting the sum of this equation, so makukuha natin yung summation ng I equals to 84.375 kilogram meter squared. Now back to our equation. Ito na yung mga variables natin. Yung only unknown na lang is the alpha. Then for the torque, so same lang din kasi pareho lang naman yung in-apply niyang force at the end pa rin siya nung merry-go-round. So wag kayong malito dito sa R kasi yung definition natin ng R dito sa torque F times D is the distance to ng distance niya from the axis of rotation papunta dito sa kung saan in-apply yung force natin. So, same lang pa din, 1.5 equals to 84.375 alpha. Yung alpha na masasolve natin is 4.44 rad per second squared. So, yung comparison ng dalawa, nung wala pa yung child, mas mabilis yung angular acceleration. Pero yung na-add na yung child, humina siya kasi yung moment of inertia dito is mas malaki as compared dito sa unang na-solve natin. So, ibig sabihin ng moment of inertia, siya yung resistance niya dun sa angular acceleration or mahirap na siyang paikutin gawa nga nung additional mass. Next. For this problem, I have already prepared the solution. I will just discuss it to you. So, for problem number 2, the flywheel of an engine has moment of inertia 1.60 kg meter squared about its rotation axis. What constant torque is required to bring it up to an angular speed of 400 revolution per minute in 8 seconds, starting from rest? Okay, so here are the known variables. Given na yung moment of inertia, 1.60 kg meter squared. The angular speed, pag speed, yung ginagamit nating symbol is omega. Specifically, ito is yung final angular speed, 400 revolution per minute, kasi mag-start siya from rest. So, ibig sabihin, yung angular speed initial or omega I is equal 0. Then, yung given na time is 8 seconds. The unknown variable is the torque. Okay, to solve for the torque, ito pa rin yung gagamitin nating equation. Pero bago natin ma-solve yung torque, kailangan munang hanapin yung alpha. So, paano nakuha yung alpha? This is the solution po para makuha yung alpha. Para magamit po natin yung rotational kinematic, kailangan muna natin i-identify yung 3 known variables. So, tingnan natin dun sa given. Meron na tayong final angular speed, the time, and the initial angular speed. Therefore, meron ng 3 known variable. So, balik tayo dun sa mga equation ng rotational kinematics. So, this time we have to just choose the appropriate equation kung saan magagamit natin yung 3 known variables, and at the same time, masasolve natin yung angular acceleration or alpha. So, ito yung nag-match kasi may tatlong known variables, si final, the initial, and the time. Then, yung isang unknown natin na angular acceleration. So, substituting all the known variables, we only have here the alpha na masosolve natin. So, nakuha natin dito class is 5.236 rad per second squared. So, bago yan, meron pala tayo ditong kinonvert na final angular speed. So, sa conversion, madali lang naman. So, yung revolution natin i-convert to rad. So, 1 revolution is equivalent to 2 pi rad. So, 1 rev is equal to 2 pi rad. Then, para ma-convert yung minute, so 1 minute is equal to 60 seconds. Kaya nakuha dito yung angular speed in rad per second. Then, next, once na nakuha na yung alpha, babalik na natin siya dito sa equation ng Newton's second law for rotation. Kaya masosolve natin yung torque equals to 8.378 Newton meter. Okay, next problem. A uniform disc with mass 40 kg and radius 0.200 meter is pivoted at its center about a horizontal frictionless axle that is stationary. The disc is initially at rest, and then a constant force 30 Newton is applied tangent to the rim of the disc. For part A, What is the magnitude of the tangential velocity of a point on the rim of the disk after the disk has turned through 0.200 revolution? For part B, what is the magnitude of the resultant acceleration of a point on the rim of the disk after the disk has turned through 0.200 revolution? Okay, let's check the solution for this item. These are the known variables or the given variables. So we have the mass of the uniform disk. So makikita natin yung keyword dito, uniform. So solid object siya. Pag solid yung object, yung I na gagamitin is 1/2 mr squared. So tandaan nyo na po yan. Then, yung radius ng uniform disk is 0.200 meter. The force is equal to, what is the force? Equal to 30. Then, yung initial speed niya or initial angular speed is 0 kasi nag-start siya at the rest. For part A, pinapahanap po is yung tangential velocity. We know that tangential velocity is equal to r times omega. Meron tayong given na r, pero yung omega dito, ang pinapahanap class is yung final angular speed, no? Na makukuha natin using the rotational kinematic. So, para makuha yung angular speed final, mag-identify muna na tayo ng 3 known variables. So, may given class na theta. Paano mo nasabing theta? Kasi naka-revolution siya. Siya yung angle between or yung angle na na-produce gawa nung rotation, no? So, yan yung angle. Okay. Okay. Ang given dito, naka-revolution yung theta mo. Yung theta natin. Or the angular displacement. Yung theta also known as angular displacement. Yan. So, yung pag-convert class, so 1 revolution is to 2 pi rad. Ang makukuha nating theta is naka-radian na 1.257 radian. So, meron tayong isa, dalawa, may natitira pang isang known variable para ma-solve natin yung final angular speed. So, pwede natin makuha yung isang unknown variable alpha using the Newton's second law for rotation. T is equal to I times alpha. Where yung T natin, pwede nating equate sa force times the distance from the axis of rotation. Yung I natin dito, since uniform disk siya, ito yung magiging equation mo. So, pareho lang siya ng 1/2 mr squared. So, then, next, yung variable m natin given, yung radius niya ng disk is 0.20. Makukuha natin class yung I equals to 0.8 kg meter squared. Then, ano naman yung torque? Using yung equation ng F times the distance from the axis of rotation. So, yung given na F natin is 30. Yung R dito is 0.20. So, paano natin nasabing 0.20? Kasi in-apply yung force 30 Newton tangent sa rim ng disk. So, ganito yung itsura niya. Tangent siya. So, ibig sabihin, yung axis of rotation, may distance siya papunta dun sa force applied equals to radius. No? Pag tangent, tatandaan nyo, lagi po yan perpendicular sa radius. So, mag-equate siya sa 90 degrees. Then, one unknown na lang, meron tayong makukuha ng alpha equals to 7.5 rad per second squared. Magagamit na natin yung alpha dito sa rotational kinematic. So, meron ka ng this time nakuha na yung alpha using yung Newton's second law equals to 7.5 rad per second squared. So, ilan na yung known variables natin? Dapat tatlo. 1, 2, 3. Then, para ma-solve natin yung final angular speed, so check your rotational kinematic kung ano yung appropriate na equation. So, magagamit natin dito is yung equation 4. Okay? So, yung angular speed initial is 0 kasi nag-start siya from rest. Plus 2 times yung alpha 7.5. Then yung delta theta natin, that is the angular displacement, equals to 1.257. Then, para ma-solve natin yung ating, so use your calculator. Nasaan na yun? Nandito tayo. So, square root, para ma-eliminate yung squared dito sa omega f. So, get the square root of both sides, no? Ay, dito. Get the square root of both sides. Kaya, yung i-input nyo sa calculator is square root of 2 times 7.5 times 1.257. Yung nakuha po na omega f is 4.342 rad per second. Then, balik tayo dun sa pinapahanap for part A na tangential velocity. So, meron ka ng omega. So, substitute na lang natin dito. Kaya yung tangential velocity is equal to 0.868 meter per second. Take note, naka-meter per second na kasi ito is the velocity tangential na linear velocity. Okay, our last item is to get the resultant acceleration of a point on the rim. This is our solution for this item. The resultant acceleration is equal to the square root of tangential acceleration squared plus the radial acceleration squared. We need to get first the tangential acceleration using the formula r times alpha. Yung alpha nakuha natin dun sa previous solution, 7.5 rad per second squared. Then, yung radius ng uniform disk is 0.20. Yung tangential acceleration is equal to 1.5 meter per second squared. For the centripetal or radial acceleration, yung equation po natin is ito, omega squared times the radius. Yung omega, nakuha natin dito sa rotational kinematic natin, 4.342 rad per second, squared times the radius 0.20 equals to 3.77 meter per second squared. Then back to our equation, substituting the two variables, we get the resultant acceleration equal to 4.057 meter per second squared. Okay, our next problem A machine part has the shape of a solid uniform sphere of mass 225 grams and diameter 3 centimeter. It is spinning about a frictionless axle through its center, but at one point on its equator it is scraping against metal, resulting in a friction force of 0.0200 Newton at that point. For letter A, find its angular acceleration. For part B, how long will it take to decrease its rotational speed by 22.5 rad per second? Here is our solution. So, nakalist down na class yung mga known variables natin. Mass is in gram, kaya convert natin muna siya to kilogram equals to 225 kilogram. Then, ang giniven sa atin is yung diameter. Kailangan natin din to i-convert sa radius. Then, notice class naka-centimeter. So, kailangan din i-convert siya sa meter. So, 0.03. Then, kalahati ng diameter is equal to radius. Makukuha natin is 0.015 meters. Next, the force equals to 0.0200 Newton. And to solve for part A, the angular acceleration, kailangan natin gamitin yung Newton's second law for rotation. Na yung torque dito mag-equate din sa force times the distance is equal to I times alpha. Next, so meron tayong force, meron tayong distance from the axis. Since ang given class is sphere, solid sphere, hindi na siya kamukha or magiging pareho dun sa previous solution natin ng pagkuha ng I. Gawa nga na sphere siya. So, based dun sa formula ng sphere, ito yung gagamitin. 2/5 mr squared. So, back to our equation. Ito na yung makukuha nating I. So, substitute nyo lang yung given na mass ng sphere at saka yung radius niya. Yung I is equal to 2.025 times 10 raised to negative 5 kilogram meter squared. Then, substituting back to our equation, yung unknown alpha natin nakuha equals to 14.815 rad per second squared. So for part A, this is our solution. Next, for part B, makukuha natin yung time para ma-reduce yung speed niya by 22.5 rad per second using the rotational kinematic. Bago yan, dapat ma-identify natin yung 3 known variables. Meron tayo ditong given na angular speed, which is, yan po yung omega final natin, 22.5 rad per second. Yung initial angular speed naman niya is 0. Then, yung alpha natin is 14.815 rad per second squared na nakuha from our previous solution dun sa part A. Then next, check natin dito sa rotational kinematic yung applicable na equation para makuha yung time. Yung equation 2, yung gagamitin natin since yung tatlo nandito and isang unknown variable lang, which is the time. Then, dividing both sides by 14.815. Ito yung magiging equation natin ng time. So, 22.5 divide 14.815. Yung nakuha nating time dito to reduce the angular speed is equal to 1.519 seconds. So, that ends our discussion for this one.